Hello and welcome to the Environmental Test and Design webinar, Conducting the Test Program, MIL Standard 810G. My name is Belinda Stashikevich and I'm the editor of Environmental Test and Design. Environmental Test and Design, which launched in 2009, specializes in the interrelationship between electronic systems and devices and their environments. This webinar is presented by Steve Ferguson, Executive Vice President of Washington Laboratories. Steve has worked in the compliance test arena for over 35 years at test labs and manufacturing companies, designing products, developing procedures, and performing tests. He presents various courses on EMI and EMC compliance. He's an INARTE certified EMC engineer and administers the INARTE approved Washington Laboratories Testing Center. Steve has done a bunch of webinars with us. To watch any of our other webinars, visit us at environmentaltestanddesign.com. This webinar today will be interactive. You'll be able to ask questions and answer polls, and we encourage you to participate. Take a look at the GoToWebinar navigation pane. If at any time you have a question, we ask you to fill out the type box and hit send. To make the screen minimize and maximize, click the arrow button. To raise your hand to ask a question or to report an issue, click the hand icon. We'll present the topic for 45 minutes, followed by a 15-minute question and answer session. Now Steve will begin the presentation.
Well, good afternoon or good morning or good evening wherever you are in the world. I do want to just kind of start out by recapping a little bit. This is the third session in a four-part series that we did this year regarding what happens when you get an RFQ that involves environmental testing. We've went through the what does the RFQ say and what does it mean to you, how to determine things, and developing a test procedure and plan. That was discussed on the previous. So as Belinda said, the recordings are available to go through those if you've missed them and want to see what's going on there. So this one deals with conducting the test program. So without further ado, Belinda, we have a poll question to start.
Okay. Attendees, please answer the following question. What role do you have in conducting the testing? Engineering support, conducting the test, witness or monitoring EUT, or other? We'll give you a few seconds to answer. And we have a few answers coming in. And about half said other, with evenly distributed answers among the other ones.
Okay. Well, I just wanted to ask this question to get a feel for the audience, see if there's any particular things. Other is pretty wide open, so we'll kind of stay with the planned program instead of any focus areas. But as Belinda said, don't hesitate to field questions. We'll try to target anything that we can. So what happens, we've got an approved test plan, the procedure got approved, and so everything possible has been defined and everybody's agreed on everything. All the test parameters, exactly what we're going to be doing is clearly written, no issues going on. All of the operational functional checks that have to occur during the process are clean. Everybody knows what you're doing, any forms, and we know what the pass-fail criteria is. And we've examined this unit thoroughly. We'd like to believe that all this acceptance criteria is fully complete. Here's the problem. This procedure may be approved, and then it comes to the test lab as to execute the test. Nobody's communicated to the lab prior to that. So they're not very conscious of what's in here. So it's up to them at the last minute to read through this and understand everything. So sometimes this can be a problem. If you have a procedure approved, by all means get it in front of the test people, the people that have to execute. They need the opportunity to do this. Now, throughout our test program, we have developed this RFQ, and it comes down to these tests that were listed here as being our test program. Some of them are smaller, some are larger, some are very detailed, but we're just taking a generic sampling here for discussion. If I tried to go through everything, we'd be here in the next year sometimes. So we're just going to kind of superficially look at some of these tests, but our reality is that we're going to discuss the generics, what happens generally speaking versus any specifics. I've got a few little considerations here on these things that we'll do, but obviously any test that's appropriate, you have to do some considerations and things like that. It's not always as clean as we'd like to imagine. So I assume that you're ready for the test. You've got the test article all prepared. It represents a production level piece. It may not have been built by production, but it's representative. We have the software to make sure it exercises all the operations within a reasonable time. And if we believe that the software isn't an important item, especially software that exercises it for tests, so we get automatic reporting, logging of events, sampling various parameters, and providing monitors to the user, somebody monitoring this thing. Quite often a lot of environmental tests happen for long periods of time, day and night, without being monitoring. They may sit in a test chamber for a while. So a way to see if everything is normal needs to be configured somehow. When do we check it? Can we set up a unit that will remotely communicate to somebody at home gets an alert if something goes wrong? Oh, absolutely. We see it routinely. So consider these kinds of things when preparing your test article. This should happen before it comes to the lab. What is the test article? Somebody needs to know and define what's configured. It shouldn't come to the test laboratory, so they have to tear it apart to see what card set or boards or whatever else is in this unit. There should be a listing from the manufacturer to say this is the configuration. Now that could be something they locally hold present. So they say it's serial number X, so serial number X was built with these things and it's in their drawing package. However it is, the identification of the test article needs to be there and be supported as to what's behind it all. You have your support equipment, monitoring equipment such as an oscilloscope, meters, various things. Do you have those things, or did you think the lab was going to have enough available, especially of any specialized equipment, to support your equipment? I got a shipment in about a week and a half ago for 3 items to be tested, and not one cable came with the package. Good instructions on setting it up, but they didn't send any cables, so we're waiting on those to arrive. The whole test program just got delayed by an inordinate amount of time. They figured, what's cables? And I don't know what they were thinking as to who's going to make them, who's going to provide them, and who's doing the wiring. Power sources. Do you need programmable AC supplies, DC supplies, something with enough power? Did you coordinate with the lab that they would have it available if you hadn't planned on providing it? Normally you have to think of anything to make the test article operate and monitor its operation needs to be provided by the manufacturer or the person sponsoring the test. The cables. Do you have something that allows the cables to come out to the outside world, coming through the ports in the temperature chambers, extending off of the vibration table, a way to secure them, something to allow the attachment where your support equipment can be somewhat isolated from the other equipment. The ability to see the screen doesn't happen when you're inside the steel box. Test fixtures. Without a doubt, this is the thing that drives me the craziest, especially in the vibration world. Little or no thought goes into some of these items. That test procedure that I mentioned earlier that should be approved should have the test fixtures clearly defined, how it would be built, and the fact is how it's going to be mounted. Sometimes these discussions are there, then nobody owns it. It's happened 4 times this year that we ended up with a vibration test and absolutely zero fixturing was considered before it showed up. Tools, ways to fix your unit. You may need some spare parts. Something could go wrong and you need to be able to have the special tools in particular. Coordinate with the lab. If it's an internal or external lab, what are they expected to provide? And support people. Don't forget that somebody needs to monitor this unit. And somebody needs to be to decide what happens if something does occur. The unit tends to fail. The acceptance criteria is ambiguous. You get something to show up that you hadn't anticipated. Now, what goes forward? Do we go forward with it? Do we stop? Somebody needs to be able to decide, and that person shouldn't be on vacation and out of reach. The person monitoring the test hopefully will be the decision point, but quite honestly, most are not to that place, depending on what happens. So, are you ready? Plan for it and be set up to come in to do the test. So what happens when we get started? Everybody arrives at the lab, they bring the test equipment in. The schedule clearly had been confirmed well in advance. No, quite often they call and say, I need to be in there tomorrow. And nobody does anything well. It usually indicates that the procedure isn't in play. I've got a test that's scheduled to start sometime soon. Of course, it's been scheduled 5 times. It does have an approved procedure. It's been coordinated with us. We're well versed in doing what we should be doing. The only problem is the test article is not being cooperative. It doesn't work in their home office well enough to go into the lab for some functional tests while it's being exposed to all the various things. Communicate. We need to get a good line of communication with the scheduling activity. Be very adept at communicating, talking with people. Sometimes the email path works well, sometimes you just need to pick up the phone. And of course, last minute scheduling and slips are going to happen. The test program is usually pushed to the last minute, and you're supposed to make up all of the lost time that happened throughout the development process. So the last minute changes are always occurring. Most every lab tries very diligently to schedule activities, but quite frankly, they can't do it. They end up having a conflict and they say, well, you didn't make your schedule the day before yesterday and you didn't call and let me know, so I had to assume that you weren't coming and I had to put somebody else in play. And then the excuse, well, this happened and whatever. And I said, but no communication pushed me out of the path where I couldn't keep the lab sitting idle. So we went forward with somebody else, and now they're going to complete before your rescheduling happens. This review of the procedure and test sequence needs to occur, especially if there's any special sequences. That lab needs to know what assets need to happen when. So coordination of the testing is clearly something that needs to be dealt with, especially when particular sequences are there. Do you need to move the equipment from one test area to another? Maybe you need to be in 3 or 4 different buildings at the test facility depending on the test program. This should be going over clearly before. Now I'm going to plead guilty to a lot of the problems. These test procedures show up with the test, and we seldom get the opportunity because of busy schedules to spend a lot of time with it prior to it coming into play. We usually, and all of the test people here particularly, try to look at this way ahead of time. And lo and behold, when it shows up, well, revision 3 is now in play instead of Rev 0, because the one we received was when the quote request came out, and it's been upgraded 3 times since. So now there are differences that we didn't know about. You need to verify this right off the bat. Verify that what you have for procedure matches what the customer expects. Go over the review checks and documentation. Am I going to be doing functional tests? Do I have a big test before starting anything, then an intermediate test through the process? What documents do I need to complete? What do I need to measure and what do I need to record? Are these documents part of the test record? Every time. I don't care what somebody says. They can't say, I just want it blocked. It becomes part of the official record no matter what. Prepared in a way that's readable, that somebody can deal with it. Monitoring needs to be clearly known. What do I look for? What changes constitutes a failure? Am I going to get alarms, or am I going to see minor variances? Sometimes these checks don't always identify everything. For instance, a ventilation fan in a unit may or may not be working, and we may not have any monitoring criteria. Should we have a monitoring method if the ventilation operation is critical? If that fan was to stop turning, do things go awry? Well, quite frankly, it could. So you need to have a way to see is these things going or not going. And by the way, a piece of tissue paper showing the air movement may not be something else when you're in some chambers that's got a pretty good airflow. You don't get to see those kind of events. I've got a note that says start the log. Very beginning, what have we got here? Start recording data. Recording is absolutely critical. It should be timely. It shouldn't be something I'll get to it mode. It should be something we do on a dedicated basis. Log entries need to be somewhat meaningful. I need to do the system checkout, make sure everything is working, that the powers are there, that we can configure cables. Can we get to the various things, or do we need to be thinking ahead to say, well, at this point I'm going to have a different cable set to reach to the outside world. We might have a few days to let things happen until then. We may be able to start storage tests while we're getting operational configuration issues varied. It's not uncommon to see a test begin and then get interrupted while we wait on something to finalize as far as support goes. But the idea is we need to walk in with knowing where it works. Don't go doing storage tests until you know it's working. Because if at the end of the storage test and if it's not working, did it happen during test or was it an infant mortality that happened before you ever got going? You shouldn't start tests until you know you've got the functioning unit that complies with all the functional testing needed. Get these logs. I indicated establish them at the beginning, some sort of date time activity and who did it. No matter how good we make entries, there's always a question that's going to show up here and there. Well, did you happen to notice whether this thing was burning or not? Because now we found something that's scorched at some inspection point. At the end of the system, when it's torn down to inspect, we find things that are loose, a loose screw. Well, who made the inspection and observation that says I inspected after the test and there was no anomalies? So put in some meaningful things. When did we do it? I've got an example of one. It shouldn't be the end of the world. And we shouldn't have to write a thesis. We can refer to data sheets where all the details are. But things to say that we did it, that we did positively do a post-test inspection. The data sheet should have that with observations and recording. And if it's there, then the entry can simply be we checked it out and made the data sheet entry. We did the inspection. Joe did it. Sam did it. Whoever was there. This should be a chronological event. We prefer to try to do electronic record keeping versus handwritten logs. A lot of people still keep data sheets out by the unit that the people are filling in as they go. But the idea is do something. Have a meaningful kind of entry place. And by all means, sketch the identity of the test article. Get this thing dealt with. I just put in here a sample of here's Model 7. This is a good place to record your serial numbers, any configuration data. Use some things here to record this. It could also go into the report. Some people put these things into a report template and they start to report as they go. Either way, make sure you have the methods recorded and somebody owns it. A nice simple log lets us look up when things happen, sequences, issues that show up, how they were resolved, things of this nature. So don't hesitate to use them. Another poll question, Melinda.
Okay, we'd like to ask the audience another poll. Is monitoring of the EUT accomplished by test item owner, test laboratory personnel, end user witness, remote control to EUT, or other? We'll give you a few seconds to answer. Okay, we have some answers coming in. And about 3/4 said, well, now a few more are coming in. Split between A and B, and a few people said other also.
Okay. Well, it's not uncommon. The laboratory personnel are frequently the people that look at this thing during the test. But some people have a manufacturer having his product done, and they're always there. They see this thing. And this sometimes becomes necessary if the monitoring can be complicated, or you need to be looking at screens and frequency variations or something that requires focus, because the test lab people need to be focused on executing the test and the test equipment. So depending on the complexity and what you're monitoring, the owner or some witness maybe need to be there to keep track of everything as it goes. Remote connections happen frequently. Somebody logs in to see that it's operating. So there's lots of activity going on here, but remember, the lab personnel's primary goal is to operate and see that the test equipment is operating correctly, that the execution happens. Data collection. We all need to have data sheets. These data sheets need to be kind of thorough with the questions to be answered. We shouldn't have a blank page for us to write in data. It should be the questions as to what needs to be supplied. For instance, where did the accelerometer, control accelerometer, get positioned for vibe? Where did we place the sensor to know that the impact was there? What did we do for thermal monitoring to determine whether the unit was stable or not? We need to have everything that the reports are going to have to be answered as part of that data sheet. If the reporting requirements say I've got to record the salinity of the water, then we need to have on that data sheet a salinity of water monitoring point. The wind speed might be a monitoring point. The sand concentration and size. Anything that we have to record in the report, there should be a provision for it in the data sheet, so that's where it lands. Seldom do we remember how to fill in all the various data points, so this getting all the points is kind of a critical element. When data points may or may not be required, put them in there, and then we can always put not applicable. By the way, when you're filling out data sheets and it's got a gap with a question to be answered, answer it. Even if it's not applicable, answer it. Blanks mean nothing. Not applicable means something. There may have to be modifications to a data sheet for any special considerations. You may need to record deviations to the procedure or standard. Okay? How many times has a test been done where the test procedure has a process change that the test engineer has followed the normal procedure instead of the deviation, because he just didn't read or remember that there was a deviation in the procedure? During this data collection and testing process, use the procedure. That has the deviations that are supposed to be used. When it's not decided, the standard becomes the default. Say that. If it's undefined, I use the standard. How did you get to the answer? Record the identification of the UT. It's awesome when a bunch of data sheets show up and you don't know what you were testing. That these data sheets that were handwritten didn't include the job number or any of these things. Get all these sheets to be complete. You should have a place to record observations, things that may not be showing up as part of the standard, but I realized that there seemed to be a sound coming from it that I couldn't duplicate. Something to record what was going on. There seemed to be an aroma coming from it of something burning, but I couldn't identify anything that was overheating. These observations can point to a potential flaw later. Record the measurements. Whatever method of measuring, whatever factor you're recording, you should have a record there. Sometimes these are provided by the test equipment software, such as making charts, etc. But things need to be identified. You could put into here the file names for the various profiles, the things that were run, the feedbacks, the thermal responses for a chamber. What happened? the conclusions. And who did this? Who did the test? Somebody needs to initial it, sign it off, whatever. Don't forget your pictures. A picture is worth 1,000 words or a kiloword. So don't forget to grab these things while the test is going on. More than once this has been an omission. These pictures sometimes are vital. It points to how things were and lets us see things that may have got omitted, or how did the actual unit get configured, what was going on with it. So now we've got all these things, so we're ready to push go. Let's verify this configuration before we start. Inspect the unit. Rattle it. See if there's loose screws going around. Shake it, turn it over, do things you need to see what's going on with it. Is the test you're getting ready to push go for correct? Did you call the wrong file up and execute or overtest the unit, or just have an improper test? And this is especially important when the unit falls apart or gets under-tested, because we may not recognize the fact that the wrong profile got executed until the report is being assembled and reviewed. Hopefully this coordination of what we did versus what the procedure said gets reconciled and everybody's pleased before the test article disappears or is subject to testing that we can't recover. It goes into a test and we can no longer do the test and have the error. Is the EUT installed properly? Is the mounting screws secure? Do we have this thing installed the way we anticipated it? More than one time a unit has been on the vibe table that should have had shock mounts installed, and somebody bolts it directly to the table. They do not get what they anticipated. The test fixture should have included those shock mounts or any other things that would make it right. Is the monitoring well established and does it work? Am I getting the feedback? Do these functional tests before the start. Does the equipment that you're running, the testing with support equipment or the UT. For example, vibration shakers have a significant magnetic field, and these can cause distortion in some of the signals we get. Monitors can become erratic, things of this nature. Temperature chambers during their airflow and shaking of the compressors have a vibration inside there. Has that been considered? Does it cause monitoring equipment to react? So when we do these functional checks and monitoring, before we are doing an aggressive thing, let's turn on some of our test equipment. See if it's a problem. Don't forget that log. Get this thing set up, the fact that we did this verification and etc. Not that it was done early on, it was done at each test, we check it. Failures. These failures do occur. We need to have some real-time monitoring going on, or we need to determine whether it passed or failed as soon as we can through the post-test functional tests and the post-test inspections. If we don't do these things very well, these things show up later and may be a problem. For instance, during an immersion test, I found a leak. It shouldn't be the first time we see that crack occurred in the box. Now, when did that crack occur? Well, was it there when we received the unit in for the testing and nobody looked closely at it? Did it happen after the shock and vibe? Had it been dropped while we're moving it from place to place? What does the log say about it? Okay. For instance, a log entry may be doing, I was moving the thing from the x-axis to z-axis on the vibration table, and it slipped out of my hand and fell on the slip table. I looked at it but didn't see anything that was a problem. That could be a log entry. These things occur. Okay. Admit it. Sometimes, even though you say, well, they're going to charge me for it, or it's a bad mark, or having no information is a killer for the test program. We don't know what happened. It's very hard to convince anybody that it wasn't a test-related failure. So getting these abnormally things from being a problem. If something did occur, get it into the logs, do the checks, bring it forward. It may have to interfere with the test he's planning on doing, but having a test go right versus we don't know what happened is really a problem. I went through an episode not terribly long ago where we didn't know when it occurred. It appeared like that somebody had hooked it up to the wrong voltage, but we didn't know that, and we had no evidence of it because it wasn't obvious that it was there. It was just suddenly not working, and the analysis took several days of failure analysis to determine that the event that occurred could not have been caused by the test that was happening, but it sure did hamper the test program. So be very conscious of things that can happen. Do the data analysis real time. It doesn't do any good to run a test and not have a clue what that data means. Does this data make sense? Always think of that. Look at this thing. Is it doing what I expected it to do? Can I account for why it's giving me the responses that it is giving me? Why does it act the way it acts? Why did that crack appear? Did a crack appear? Looking at these elements is very important to us, and the test people have to take care of this. Does that vibration sensor or the accelerometer for responses get looked at? When we do a pre and post test sweep to determine if things changed, does anybody look at all the lines to say it stayed the same? They should. Did they record in the log that they did? It's important to know that this happened because nobody else knows you did it, so it just suddenly appears. So if you look at it and say, I checked this thing, then we shouldn't have surprises when the report is being prepared or the end user is actually reviewing the report for approval. That's not the time for the surprise events. All of us through the process have to be responsible to make this data and reporting work right and to take care of the problem. Handling the non-compliance. What happens if it fails? You need to have that process for reporting it, have a process for holding the job or proceeding, and have a process for documenting and approving the handling. Non-compliances or apparent non-compliances need to have a good way of handling them. What are we going to do? If you suddenly a non-compliance or what appears to be a non-compliance shows up, we shouldn't have to be spending the next 3 days figuring out what are we going to do about it, because it delays everything. There should be identified people in the program to contact. They need to be able to make the decision, and you need to let them know that things are holding pending that. They shouldn't be saying, well, you reported it, but you went on, I guess. That communication needs to be clear. Who's doing what? What are we going to do next? How are we proceeding? Document those things. Have that going ahead of time. Also, deal with these data analysis things that we have by doing this post-test functional. It is so bad that if we don't check the unit into the test because, oh, well, we're running a little bit late, it's time to go home, I'm in a hurry, so we didn't do this. The next morning the unit comes in, you power it on, and it's not working right. Well, was it working right when you finished the test? Did you do the test to find out? These things need to be recorded then and what you did to validate it. So racing off in the afternoon because I'm running a little bit late probably can lead to more issues. Did the unit just die overnight? Did the power on blew a fuse or something? Nothing happened during the test. It was just a new item that happened. So we come in the next day, we move it over to the next place, turn it on to check it, and now it's not working. Did the movement happen, cause it to fail, or was it truly test related? If we can't decide, we end up going back and redoing that test, and it's subject to spending several days in that kind of an event. Let's talk about a few things we need to consider. When I'm doing temperature and humidity considerations, when I'm doing those tests, I need to look at the airflow around the UT. It shouldn't be sitting against the wall so the airflow isn't around the unit. It should be up on a stand, maybe sitting on the base is an acceptable configuration. Do we have so much unit that we can't get any airflow? Do we need it? How about condensation? Do we have things that occur regarding those airflow movements that prevent us from getting the test to do this? The transition from one temperature to another one. Realize that the temperature transition is not a linear event. When they say we're changing temperatures at 2 degrees per minute, we may not notice that it comes in, and when it approaches this, that slows down somewhat, part of the preventing an overshoot. These ramp rates also need to be realizable. This may call for 10 degrees C per minute. It takes quite a bit of chamber and boosting to cool things at that rate, especially if you've got a high temperature mass that you're having to change. We can change the air in the chamber, but getting the chamber to stabilize there is not necessarily so quick. Realize that some of these things are very difficult to attain, and we need to adjust for some of those items. The user needs to be aware, because they may not be conscious that it's happening that way. They think that 10 degrees per minute is something that's just going to be, boom, it's there. So communicate, realize this. Stabilization of the test article for temperature. Do you have a method to determine what it is? A lot of times the stabilization is based on being at a temperature for an amount of time. The analysis of the mass told us to do that and stay there. We could put in monitoring situations for the unit, but sometimes it gives us a false thing too, where we get a mass that tends to be stable, or it's not changing very rapidly, so we think everything is stabilized. So looking at how we're determining stabilization needs to be part of your plan. Quite often a cyclic temperature profile isn't used for the UT response. We're going to cycle at this many degrees for this time period, this ramp rate, and stay it here for X time, and then the natural temperatures are changing. So no matter what the UT actually got to, the chamber or the environment is what we're varying, and that needs to be the conscious. Realize that with humidity, temperature changes must allow for a humidity variance, especially if these temperature changes are somewhat rapid. You've got to change, the humidity will vary, and then you can recover it maybe, but it's going to change at some function. So realize holding a solid humidity while we change temperature, especially with rapid changes, isn't real. Humidity control can be affected by the environment. We shouldn't believe that we can get 5% humidity when it's the middle of summer in the tropics or some other place like it, like Florida, or in our case, Maryland. This humidity out in the environment will affect our ability to achieve some things. So consider that when we're doing the test, that we may have a limitation and not have that same limitation in another time of the year. Sometimes you may need to create an environment to allow your chamber to get there, chamber inside a chamber mode. It has been done before. Realize that the high humidity and freezing temperatures are not feasible. You're not going to make 95% at -8 degrees C. Not going to work. So people that believe it's going to happen, do that. Rain, salt, and immersion considerations. Now, by the way, I'm just picking these because I said that's our test program. Pre-test inspections need to happen. We need to log observations, confirm the procedure parameters. Are the necessary parameters specified? For example, temperature before exposure. If I'm doing a rain test, does the unit get a 27-degree temperature or above water temperature before exposing it, or 10, or nothing? Depends on the application. These kind of events sometimes are omitted in the procedure because they're more focused on the details of how to do it, how to check it, instead of getting all these considerations absolutely specified. Wind speed. Did we verify it? We need to look at it this time. We can't believe because, well, the last time it was right. Droplet size for the rain. Any rotation, exposure, or angles of exposure for items that are exposed to dripping water, etc. And by the way, why are we doing a rain test if immersion test is specified? In our case, it was. Usually if immersion is specified, the rain test requirement kind of disappears because I'm going to put it to a worst case event by immersing it. But quite honestly, both tests are called out frequently. So be aware that just because it doesn't make any sense doesn't mean it isn't required. Salt concentrations, usually we're used to that 5% in HCl, but quite often this test spec may include sulfur dioxide. And do we do during the test, do we do the fallout rate? Do we confirm that it's there before the test, during the test? Do we monitor it? Do we check it? Is it feasible for the salt fog fallout to be checked, written down, and nobody sees whether it's right or not? So we go on, and after 14 days of exposure, we realize that on day 3 and 4 it wasn't working right. Does that invalidate all the tests or just days 3 and 4? Out of a 14-day test, I've lost my days to be correct. How do I handle the situation? So catch these things real time, get an adjudication on what we're supposed to do about it. Consider all of those factors. Vibration and shock. Do you know where the control accelerometer location is? Did it get documented that cleanly in the procedure as to where you're going to place the various things? How about response monitoring? Is it present even if it's not specified? Quite honestly, I think that response monitoring is something we should do all the time. Whether it's called out in the procedure or not, we need to have a method to look at it at the EUT to see that is it varying from what we saw at the beginning of the test. As responses start changing, we're getting an indication that something about the test article is varying. We need to be able to adjust based on that. The pre- and post-test exposure sweep for the response variance. It's not called out, but a 2-minute sweep, sign sweep through a range before and after while we're still configured there gives us a more clean indication of something that could have happened. Observe, observe, observe. I can't say it enough. Are the responses changing? If a person sets the unit up on the vibe table, starts the profile and says, yep, that's working, and goes back to the desk for the next 4 hours, is anybody looking as to what's happening on that table? Are we seeing it start to come apart? No, not if we're somewhere else. We need to frequently look at how things happen. Quite honestly, it's a boring job. You sitting there and concentrating on that response, but you need to be at least frequently looking at it. So if things start to occur, I've got an indication. Should know what they are at the beginning, and when I come back, are they becoming different? Your observations need to consider that throughout the exposure. Did the cross-axis monitoring measurements change? Did something go wrong to cause a cross-axis deviation? Do we hear things going on? Quite honestly, a lot of people don't like the sound of the vibe table going on, so they don't even listen. They shut down, put earplugs in, etc. But quite frankly, if a unit starts coming loose at the fixture, you may hear some significant audible changes, and it might tell you I need to look around to the back and say something went wrong here, because I'm hearing the change. So don't hesitate to be observant. You need to be clearly observing what's going on and following it, seeing that it's not being something different than you planned. Or is the plan to find it fail? Is the test fixture appropriate for what we're doing? We all look at this every time we're here and we see the unit, we know it's supposed to be on X, then the customer never considered a fixture. So he does a attachment to the table with common hardware, some sort of clamping mechanism, but is it appropriate? Quite frankly, the fixture and the evaluation are things that go wrong all the time. We can lead to an overtest or failure to test in a manner that the UT is going to see. A rack-mounted piece of equipment should be looked at in a rack. If it's always going to be put in a rack to do the operation, why would we not consider the rack as part of the fixture? and any shock mounts or housings or support structure that needs to happen. Is the EUT configured in the fixture properly? Quite honestly, we've had multiple times when a unit comes in with multiple connectors on it and only 2 of those connectors get a cable attached. And there's 15 or 20 of them. Well, I've got one of each of the types. I've got the serial cable and the high density cable. And I've got 4 of each there and we only load 1. Well, the connectors change how the unit acts. It's part of the mats. It puts stresses on the boxes. So all of them need to be in play with the cable being there to provide the loading. Any structural supports that are in the mount should be there. Shouldn't be left hanging out if I'm going to put a mounting structure into the rack or any installation. Consider that a test article needs to be in a manner that represents what's going to happen to it. Getting pre-test data evaluations needs to consider this. Sometimes customers will come in, attach the unit directly, monitor it and say, okay, that didn't work very well. And in reality, they're always going to have shock dampeners. So the harshness of the shock and vibe is not the same as what they tested. So they go back and redesign and get all these things resolved to do something that never would have been a failure had they properly configured it. Data review, look at it. Just analyze the data and examine it. A pre and post-test response curve, did things change? Inspect, check for non-functional things like breakage, cracks, looseness, rattles, things of this nature. It's not just a saying, is it operating? It's an awesome event to watch an item go up in smoke on the vibe table because we didn't look at it and things were changing. And by the way, I've seen that happen. And I'm burned on the table. Another poll question, Belinda.
Okay, we'd like to ask the audience another question. Do you do cross-axis monitoring during vibration tests? Always, if specified, never, or what are you talking about? We'll give you a few seconds to answer. We have a few votes coming in with about 80% saying B, if specified.
Okay. Well, if you're doing an 810 test, it is specified by the standard that you should look at this and control how much cross-axis vibration you get. So we should be thinking always, not if somebody asks for it. It's part of our program to see that we are doing the testing in the orientation that we planned. The cross-axis tells us that we're not arbitrarily doing something other than we intended. For instance, a high cross-axis test for the Y parameter, when we're trying to do the X parameter, could indicate that a failure or a pass could be related to some cross-axis event. Now, we know we're going to rotate it to the other event anyway, but it may not be something we see. And when people start analyzing their failure mode, if it fails in the X-axis, and they don't know that they was having a cross-axis problem in the Y, they don't go looking for things that could have happened that way. They start fixing a problem based on what it appears to be. So consider doing these things. And by the way, did anybody answer what are you talking about, Belinda? Didn't hear. Okay, it's not a problem. I'm glad everybody didn't choose that one anyway, because at least they're aware of what's going on with it. Let's try to do a little bit of a summary here. Schedule it. Arrange early and communicate regularly. Get this test program going on way ahead of time. Forecast to the lab when you think realistic things happen. Keep the lab informed as issues change that. Start confirming. The lab will coordinate with you. Almost all of them have follow-up things to make sure everything's still on track. But don't depend on it. Help keep the lab communicating. Don't expect schedule compression. It seldom happens. If you think I'm going to make up for it by doing 3 shifts instead of 1 or something else, unless you've arranged for it, it's likely not to be an available element. Every project that you do should not be a crisis management situation. Customers that do this get to be well known, and the labs just absolutely charge them more because they have to. They have to try to jump through hoops every time, not just occasionally, every project. And why do they do it? Because program managers put on a schedule, and as things slip, they don't allow you're going to make up for it mode, or they ask for that, and nobody makes the significant changes. So we should take care of this. Never should we first hear about a project the day before it's needed. Nobody thought about it when they did the job or started the process, the design process, 4 months ago. It should have been brought forward at that time. Prepare your equipment, your UUT, your support equipment, everything needs to be prepared. Do you have the cables that will reach out to the outside the chamber? Do you have to have an outdoor antenna attached? Did you put a valid cable for it? Process for handling situations. They will happen. These things are going to occur. Not everything is considered, and when you do consider everything, the UT acts up to give you a new one. You're going to be facing some of these events. During the execution, monitor, inspect, analyze through the whole process. Not just believe at the end of the day we're going to find out, or at the end of the project we'll find out what happened. Constantly look at this thing, inspect it, check it. What's going on here? It shouldn't be a surprise when we find something that happened 3 tests ago. Keep those logs going. Everything, measurements, inspections, observations. Record what we're doing. When we start making logs, I'll catch it up at the end of the week. Too many things happen. We're too busy. Too many events occur to have any record of what's going on. Make logging an integral part of the job. You can collect data and throw it away. You can't get it later. Okay? So do a data collection thing that makes sense. Get your photographs, measurements, record this. What is this item? A lot of pictures get taken that get discarded. They're just extras and things like that. But sometimes it helps us keep straight. So organize your event. A major test program has a lot of opportunities for errors, so paying attention throughout the process is a requirement. Keep looking at what I'm doing. Don't drop the ball. Don't think it's just a standard thing. All things are standard, but your deviations will kill you. Document it. You will not remember the details. Put it in play early. Record conversations. Discussions are not remembered, so record them and have others confirm the record. What I like to ask all of our people to do is when you discuss something that is part of the record, write an email, get a confirmation back that this is what everybody agreed. File it. Put it into the test record files. Okay? You should always consider this. Who records it, by the way? An email comes to 5 people within the lab. Who's the one that should be doing it? Well, any communication should be addressed to somebody and others copied. If I address an email to 5 people, who acts on it? Nobody? Everybody? Some? You got this arbitrary thing going on. I like to believe that we use some common sense, and if it's addressed to multiple people, the first name on the list should see that it happens. It may be the third name that actually needs to record it, but whoever's first needs to look at it and say, I need to make sure this got addressed, and see who does it. Don't try to avoid it. All of us make this thing work or not work. So whoever it's to, if it's the wrong person, then readdress it to and get the right people doing it. During packaging of the equipment after the test is not the right time to ask, when did the bubbles show up under the touch screen? I've got a delamination under the glass and I didn't see it until I'm putting the equipment away to ship it back to its customer. It's not the right time. We should be recording events like that as we go. How about corrosion, paint, loose screws, all these things? I want to be perfectly clear. Observe it, understand it, document it. The records are just as significant as doing the test. Pay attention to what we've got. Our next in the series is reports, conveying the message, scheduled for November 19th. Belinda, do we have any questions?
Yes, Steve, we have a few. Thank you so much. We'd like to have a call for final questions. Please enter any last questions you may have in the navigation pane. We've received quite a few inquiries on where to get additional information on this topic. There's a vast amount of content on our site, environmentaltestanddesign.com. You can also email us at info@etdnews.com with specific needs, and we can direct you accordingly. Steve, here's a question for you. Do you include the test log in the report?
Sometimes the test log is part of the record, and it should be clean enough and readable enough to where we can scan pages if it's handwritten, electronically print the log, so we keep that in the file. It can be a great appendix to a report to show these are the events, and it can also point to the fact of things that may not be understood in the report, may not be called for, but do this. So in the process of thinking that way, whoever's making the entries needs to consider that, yes, this can become public. It goes to the customer. So don't make entries like the customer was a jerk, but we did it anyway. So that's not the right thing to do, because these records do become part of the job. It is an official record. Make it part of that. Convey it. I recommend highly putting it in as an appendix. Anything else?
Okay. What is a cross-axis response?
That's, I think that when we discussed it, most everybody answered that they kind of knew, but it's basically a cross is not the axis that we're testing in, it's the opposite direction or 90-degree direction in both the vertical or horizontal opposite way. So if we're testing Y, it could be an X and a Z response to see if something's going on there. And by the way, monitoring this thing could point to a fact that the test fixture is faulting. Not necessarily the UT, but the fixture could be putting a cross-axis event. Is that considered a failure? Not necessarily. The standard calls for you to do control of the cross-axis, but if the fixture design that's properly built induces the cross-axis, then you're just simply recording it. Be aware that if it should not be there, you need to control it, but if it should be there because of the design, you have to manage it and discuss it in your report that the cross-axis was because we had it mounted on shocks or the configuration allowed for this to dampen things. Just a good discussion point. Next.
Okay. You pointed out several considerations. Are these items not documented in the approved procedure?
Most of the time they are. When I look at considerations, I try to think about things that are frequently not done that may or may not be an event that you show up or not. It may not be something that is considered to be a high-risk element, so it's not conveyed. Sometimes reviewers of procedures restrict what's there. For instance, I usually like to put in a sample of what the output will look like a chart for a vibration in a procedure. This is what our report will show. A lot of reviewers, and more than I'd like to admit, say, well, no, you don't put that in the procedure because that's already pre-programming the test. You mark all over it, it's a sample, it gives you the appearance, it tells you this is how we're going to do it. But some reviewers absolutely balk at it being there. So suddenly the report gets it and they're saying, well, what's this? Why is it looking like this? We expected another something. So sometimes these things are important. Get as much in the procedure as you can. Two things happen. It gives the reviewer what it's going to look like, and it also gets the lab people, this is what my expectations are. If what you're doing doesn't coincide with that, we have a disconnect and we need to communicate. Anything else?
Okay, one more. I sometimes notice that the person conducting the test is not aware of what the data means. Is this normal?
It can be. A lot of times a representative gets sent because they know how to operate the unit well, and they're not versed in the test and evaluation. So they don't know that there's some oddity going on. Quite frankly, most test technicians and engineers are very conscious of what they're doing and what looks unusual, and they communicate. They discuss it with the reviewer, try to get agreement or whatever, or prompt them into getting their people to decide what we should do here. It's not unusual to have limited knowledge in the various test aspects because they're focused on their part of it. For instance, if you've ever dealt with a digital designer and try to get them to understand the RF world, it seems like it's a challenge sometimes. Okay.
Okay. Steve, thank you again for your time and expertise. Webinar attendees, if you have any more questions we didn't answer here today, please send us an email at info@etdnews.com. A recording of this webinar will be available on our website, environmentaltestanddesign.com. We will also send a link to all participants shortly. Thank you for attending.